Hi, in this example, I'm going to solve another case of linear approximation using differentials. In this case, the setting is like this. The demand function of manufacturing an object is given by this expression, which is Q of P equal 20,000 over P, where Q represents the weekly sales, number of products sold, at the price P. The product's price is $5, $5, but the sales department wants to change the price to $4.95. Now, using differentials answer, will the company sell more or less products, and how many of them? That is to say, how many will we sell more or less with this change of price? So let's see. We have here the same expression in blue that we'll be using all along. Now, so let's rewrite it in more fashionable way for this case. Now, instead of differential of y, we'll be looking for a differential of q, which will stand for differential of product sold. Instead of f prime, we'll be looking for a q prime. Now, here this price, we'll be looking for this case. For this case, will be the price actually that it's being sold at this moment, which is $5. Here 5. So and the differential of x, we're having a differential in this case, a differential in price. So let's find out each of these parts of this formula. Let's start by this q prime of 5. So we had that this q of p, it's equal to 20,000 over p. So we have to find its derivative. So in order to find it, I'm going to rewrite it in this way. It will be 20,000 times p raised to the negative 1. So starting from there, I'm going to continue down here. Its prime will be q prime of p. Will end up looking like this. Will be negative 20,000 over p squared. Now let's find out q prime of 5. It's going to be q prime of 5. Let's say negative 20,000 over, in this case will be 5 squared. So this q prime of 5 will look like this, would be negative, oh, this is a very ugly, negative 800. That is. So we got along with this part. This is q prime of 5. Now let's work with differential of price. Differential of price, well, that's pretty easy. Well, differential of price is the final price, which is in this case is 4.95, will be minus the initial price, which is $5. So in this case, the differential of price would be negative 0.05. We are lowering the price, and we got a negative differential, which makes sense. Now let's we got all the pieces. Let's put it inside our formula. This will be differential of quantity be equal to, here's q prime of 5, which we found to be negative 800, will be times the differential of price, which we found to be negative 0.05. Now from here, to continue down here with blue, once we multiply these two guys, the differential of q differential of q will be equal to 40. That is to say, this is a differential of products sold. That is to say, we'll be selling 40 products more, because this is a positive quantity. How it is how can we go deeper into this this idea? I'm going to show you something. Now I'm going to make another case. Let's suppose we, instead of lowering the price, let's suppose we will rise the price. Let's say I'm going to differential price. Let's say we rise the price instead of 4.95. Let's say we rise the price to $5.50, which is a lot. That's like 10% raise. It's crazy. So the differential of price would be positive 0.5. So I'm going to do the same operation here on the right of this formula. With differential of q will be equal to this q prime of 5 will not change. Will be times the differential of price, that in this case is going to be a positive number, will be positive 0.5. So our differential of Q will be now negative negative 400. That is to say, if we raise the price 50 cents, which is a lot, it's 10% of the price, we will sell 400 products less than we would expect with the normal price which is $5. So I'm going to show you something extra, something else. Let's say I got here, I'm going to write here in white. What would be the expected weekly sales? The expected weekly sales would be something just like this. Would be Q. How many products will you sell with the actual price, which is $5? So that is to say, we're going to we have 20,000 over 5, and that's equal to 4,000. That is weekly. You would expect to sell 4,000 products. Now, if you lower the price 50 cents to get to this 4.95, you will be expecting to sell more products. I mean, I'm going to write it here in pink. The expected sales. So if you lower the price, you will be selling 40 products more. In this case, by lowering 5 cents. So would be the expected sale will be the actual price. In this case, will be plus 40 because we'll be selling more due to the fact that we lower the price. So we'll be expecting to sell 4,040 products. Now, for the case that we rise the price, our expected sales will be 4,000 minus, in this case, minus because we are rising the price, we are selling less products. We'll be selling 3,600 products for that week.